Okay, welcome back to Mtale TV. My name is Robert Mtale and I'll be your tutor.
Question 1 reads, Chemistry is a broad part of science with many branches. Part A says, state 3 branches of chemistry. The 3 branches you should write are organic chemistry, inorganic chemistry, and physical chemistry. Now, since this is a revision video, allow me to explain more about the 3 branches of chemistry in detail. So organic chemistry simply deals with carbon compounds, while inorganic chemistry deals with compounds that do not contain carbon. And physical chemistry looks at how energy and matter interact during chemical reactions. Now let's look at Part B. It reads, despite its vast usefulness, chemistry has its negative effects. Part B1 state one reason why chemistry is important in society. Chemistry is important because it is used to manufacture medicines and drugs that treat diseases and save lives. That's the answer for Part B1. Moving on to question B2. It reads, give one negative effect of chemical activities on the environment. Chemical factories release harmful gases such as sulfur dioxide into the atmosphere, which causes acid rain and pollutes the environment. So that's how you get your 5 marks. Remember to start with the simple questions during the exam. Moving on to question A2. It reads, a teacher placed an open bottle of perfume in front of the classroom. To start with, learners at the back of the classroom were not able to smell the perfume. After a few minutes, the smell of the perfume was detected throughout the room. Part A says, explain the observation using the kinetic theory. Now pay very close attention and let me explain this properly. The perfume molecules in the liquid state gain enough kinetic energy and escape into the air as a gas. These gas molecules are in constant random motion. They move from the area of high concentration near the front of the classroom to areas of lower concentration at the back. This process is called diffusion. The key word the examiner wants to see here is diffusion. Make sure that word appears in your answer. Part B says, state and explain how the time taken for the smell to be detected in all corners of the room could be reduced. Simply increase the temperature of the room. When temperature increases, the kinetic energy of the perfume molecules increases, causing them to move faster. This means diffusion occurs more quickly, reducing the time taken for the smell to spread to all corners. So remember, higher temperature means faster moving particles, which means faster diffusion. That is the concept the examiner is testing here. Part C says, draw diagrams to show the arrangement of particles in liquid perfume and gaseous perfume. Now listen very carefully here because this is where many students drop marks. Diagram questions are not difficult once you know exactly what to draw. Let me describe both diagrams using simple words. For the box labeled perfume in liquid state, draw a box. Inside the box, draw circles that are close together. They should be touching or nearly touching each other. Arrange them in a slightly irregular way, not in a perfectly straight line. Think of it like a crowd of people standing very close together with almost no space between them. There are no big empty gaps between the particles. For the box labeled perfume in gaseous state, draw another box. This time, draw circles that are very far apart from each other. Scatter them randomly all around the box with lots of empty space between each circle. Think of a few people spread out across a very large field. The particles look random and spread out all over the inside of the box. So to summarize, close together with small gaps for liquid, far apart with lots of empty space for gas. Keep it simple and neat. That gives you your 6 marks for question A2. On to question A3. It reads, seawater can be purified at sea level using the apparatus shown. The apparatus in the diagram shows a round-bottomed flask labeled A, a thermometer labeled B, a condenser with parts labeled C and D, a collection flask labeled E, and a heat source labeled F. This apparatus is used for simple distillation. Part A. Part 1 says, suggest the maximum temperature that could be recorded by the thermometer B during the experiment. The answer is 100 degrees Celsius. Now let me explain why. Thermometer B measures the temperature of the water vapor as it rises from the flask and enters the condenser. Pure water boils and turns to vapor at exactly 100 degrees Celsius at sea level. So that is the maximum temperature the thermometer would record. Part A Part 2 says, how does the temperature in Part A Part 1 compare with the boiling point of seawater? The temperature recorded by thermometer B is lower than the boiling point of seawater. Now the reason for this is important. Seawater contains dissolved salts. When salts dissolve in water, they raise the boiling point of the water above 100 degrees Celsius. This is called boiling point elevation. So seawater boils at a temperature higher than 100 degrees Celsius, but the pure water vapor that rises still has a temperature of 100 degrees. Part B says, in which labeled piece of apparatus does each of the following processes take place? Part B Part 1. Evaporation. The answer is A. Evaporation takes place in the round-bottomed flask where the seawater is being heated. The water gains enough energy and turns into vapor. Part B Part 2. Condensation. The answer is D. Condensation takes place in the condenser. This is where the water vapor is cooled down by cold water surrounding the inner tube and turns back into liquid water. Part C says, explain why filtration cannot be used to purify seawater. Filtration cannot be used because the dissolved salts in seawater are soluble. Filtration only removes insoluble solid particles. Since salt particles are dissolved and too small to be trapped by filter paper, they would pass straight through with the water. So the key word here is soluble. Salt is soluble, which is exactly why filtration will not work. That gives you your 5 marks for question A3. Let us look at question A4. It reads, the elements X, Y, and Z have the following nuclides. X has atomic number 9 and mass number 19. Y has atomic number 11 and mass number 23. Z has atomic number 6 and mass number 12. Now since this is a revision video, let me first identify each element before we answer the questions. X has 9 electrons. The electron arrangement is 2, 7. That makes X fluorine. Y has 11 electrons. The electron arrangement is 2, 8, 1. That makes Y sodium. Z has 6 electrons. The electron arrangement is 2, 4. That makes Z carbon. Keep these identities in mind as we go through the parts. Part A says, draw the dot and cross diagram showing outermost shells only for the compounds formed by. Part A Part 1. X and Y. X is fluorine and Y is sodium. Now sodium has 1 electron on its outer shell, and fluorine needs 1 electron to complete its outer shell. So sodium gives its 1 outer electron to fluorine. This forms an ionic bond. The compound formed is sodium fluoride. Now let me show how to draw this diagram clearly. Draw 2 separate circles side by side. The left circle represents the sodium ion. Since it has given away its electron, its outer shell now has 8 electrons. Draw 8 dots or crosses evenly around the circle. Write a plus sign outside the circle to show it is now positively charged. Put a square bracket around the whole circle. The right circle represents the fluoride ion. Since it gained 1 electron, its outer shell now also has 8 electrons. Draw 8 dots or crosses evenly around this circle. Write a minus sign outside to show it is now negatively charged. Put a square bracket around this one too. The 2 ions sit next to each other. That is your complete dot and cross diagram for the ionic compound sodium fluoride. Part A Part 2. X and Z. X is fluorine and Z is carbon. Carbon has 4 electrons on its outer shell and needs 4 more to be stable. Each fluorine atom has 7 electrons and needs just 1 more. So carbon shares 1 electron with each of 4 fluorine atoms. This forms covalent bonds. The compound is carbon tetrafluoride, written as CF4. Now let me explain how to draw this clearly. Draw 1 carbon atom in the center. Show 4 electrons as dots on its outer shell. Now draw 4 fluorine atoms positioned around the carbon, one on top, one below, one to the left, and one to the right. Each fluorine has 7 electrons shown as crosses on its outer shell. Between the carbon and each fluorine, there is a shared pair of electrons. 1 dot from carbon and 1 cross from fluorine overlap in the space between them. When you count all the shared pairs, carbon ends up with 8 electrons and each fluorine also ends up with 8 electrons. Everyone has a full outer shell and everyone is happy. Part B says, compare the electrical conductivity of the two compounds in Part A Part 1 and Part A Part 2. Sodium fluoride is an ionic compound. It can conduct electricity when it is molten or dissolved in water because it has free-moving ions that carry the electric charge. Carbon tetrafluoride is a covalent compound. It cannot conduct electricity in any state because it has no free ions and no free electrons to carry the charge. Part C says, state the location of element X on the periodic table. Write this. Element X, which is fluorine, is located in period 2 in group 7. It is a nonmetal found in the halogen group. The period tells you the number of electron shells, and fluorine has 2 shells. The group tells you the number of outer electrons, and fluorine has 7 outer electrons. That is how you confirm its position. That gives you your 7 marks for question A4. On to question A5. It reads, study the experimental setup shown. The diagram shows a flask being heated with a mixture of ammonium chloride and excess magnesium oxide inside. A piece of damp red litmus paper is held above the mouth of the flask to test any gas that is produced. Part A says, why should the litmus paper used be damp? This is because the ammonia gas produced can dissolve in the moisture on the paper. Ammonia only changes the color of litmus when it dissolves in water to form an alkaline solution. So the moisture is essential here. Without it, the gas cannot react with the litmus paper and no color change would be seen. Part B says, describe what would be observed in the experiment. The damp red litmus paper turns blue. This shows that an alkaline gas, which is ammonia, has been produced during the heating of ammonium chloride and magnesium oxide. Part C says, write a balanced chemical equation including state symbols for the reaction in the experiment. The equation is 2NH4Cl solid plus MgO solid gives MgCl2 solid plus H2O liquid plus 2NH3 gas. Make sure your state symbols are included because the question specifically asks for them. Part D says, ammonium chloride is a soluble salt. State a suitable method for its preparation and the chemical reagents used. Method: titration, followed by evaporation and crystallization. Reagent 1, ammonia solution. Reagent 2, dilute hydrochloric acid. Now let me explain this quickly. Since ammonium chloride is a soluble salt, you cannot make it by a simple precipitation method. Instead, you use titration where you carefully add ammonia solution to hydrochloric acid until they exactly neutralize each other. You then evaporate the solution and allow it to crystallize. Part E says, it is recommended that this experiment is conducted in a fume hood. Why is this important? Write this. Ammonia gas is toxic and has a very strong irritating smell. Conducting the experiment in a fume hood prevents ammonia from escaping into the laboratory and causing harm to the students and teacher in the room. That gives you your 8 marks for question A5. Let us look at question A6. It reads, crystals of copper 2 sulfate, CuSO4.5H2O, can be prepared from a reaction of copper 2 oxide with sulfuric acid. In an experiment, 7.95 grams of copper 2 oxide is mixed with a solution containing 7.35 grams of sulfuric acid. Part A says, construct a chemical equation for the reaction between copper 2 oxide and sulfuric acid. The equation is CuO plus H2SO4 gives CuSO4 plus H2O. In words, copper 2 oxide plus sulfuric acid gives copper 2 sulfate plus water. This equation is already balanced as it stands, with one of each compound on both sides. Part B says, determine the limiting reactant. Now this is a mole calculation question. Let me walk through it step by step so you understand the method. First, find the moles of copper 2 oxide. The molar mass of CuO is 64 plus 16 equals 80 grams per mole. Moles equals mass divided by molar mass. So 7.95 divided by 80 equals 0.099 moles. We round this to 0.1 moles of CuO. Now find the moles of sulfuric acid. The molar mass of H2SO4 is 2 plus 32 plus 64 equals 98 grams per mole. Moles equals 7.35 divided by 98 equals 0.075 moles of H2SO4. The equation shows a 1-to-1 ratio, meaning you need equal moles of CuO and H2SO4. You have 0.1 moles of CuO but only 0.075 moles of H2SO4. Since sulfuric acid has fewer moles, it runs out first. The limiting reactant is sulfuric acid. Part C says, hence, calculate the mass of copper 2 sulfate crystals expected to be produced. Since sulfuric acid is the limiting reactant, we use its moles for the calculation. We have 0.075 moles of H2SO4, and from the equation, 1 mole of H2SO4 produces 1 mole of CuSO4.5H2O. So moles of crystals equals 0.075 moles. Molar mass of CuSO4.5H2O equals 64 plus 32 plus 64 plus 90 equals 250 grams per mole. Mass equals moles times molar mass equals 0.075 times 250 equals 18.75 grams. Part D says, on crystallization of the solution, 16.3 grams of crystals of CuSO4.5H2O were obtained. Calculate the percentage yield. Percentage yield equals actual yield divided by theoretical yield multiplied by 100. Percentage yield equals 16.3 divided by 18.75 multiplied by 100 equals 86.9%. That gives you your 8 marks for question A6. Part 1 says, group where all the elements have a stable electronic arrangement in the outermost shell. The answer is group 0, also known as the noble gases. Now let me explain. Elements in group 0 have a completely full outer shell of electrons. This makes them very stable and almost completely unreactive. They do not need to gain, lose, or share electrons with other atoms. Part 2 says, number of electron shells in astatine. Astatine is in period 6. The period number always tells you the number of electron shells. So astatine has 6 electron shells. Part 3 says, formula of the compound formed between fluorine and strontium. Fluorine is in group 7 and forms a 1- ion. Strontium is in group 2 and forms a 2+ ion. To balance the charges, you need 2 fluorine atoms for every 1 strontium atom. So the formula is SrF2. Part B says, zinc is found in the block of transition elements. Part 1 says, give one general property of all transition elements. Write this. Transition elements form colored compounds. Other acceptable answers include, they act as catalysts, they have variable oxidation states, or they form complex ions. Any one of these will earn you the mark. Part 2 says, give one property of zinc that is not typical of other transition metals. Unlike most transition metals, zinc only forms one oxidation state, which is +2. Most other transition metals show variable oxidation states. That gives you your 8 marks for question A7. Let us look at question A8. It reads, a list of metals is given as follows: aluminium, copper, calcium, iron, gold, lead, magnesium, sodium, silver, zinc. Choose the one metal responsible for the following descriptions from the list. Part A says, it is used in sacrificial protection to prevent iron from rusting. The correct answer is zinc. Zinc is more reactive than iron, so it corrodes first, protecting the iron underneath from rusting. Part B says, it is resistant to corrosion and extracted by electrolysis. The answer is aluminium. Aluminium has a protective oxide layer that resists corrosion, and it is extracted from its or bauxite using electrolysis because it is too reactive to be extracted by reduction with carbon. Part C says, it is the more reactive component of brass. Zinc is the correct answer. Brass is an alloy made of copper and zinc. Between the two, zinc is the more reactive metal. Part D says, it causes brain damage. Lead is the answer. Lead is a toxic heavy metal that causes serious neurological damage, especially in young children. Part E says, it forms different simple basic oxides. Simply iron. Iron forms two different oxides depending on the conditions, iron 2 oxide and iron 3 oxide. This is because iron has variable oxidation states, which is a property of transition metals. Part F says, a metal that would form a colorless solution when added to red-brown solution of iron 3 sulfate. The answer is zinc. Zinc is more reactive than iron and displaces it from the iron 3 sulfate solution through a displacement reaction. The iron 3 ions are removed from solution, and the zinc sulfate solution that forms is colorless. That gives you your 6 marks for question A8. And that completes the whole of section A. And B9 reads, the following diagram shows apparatus that can be used to electrolyze concentrated, aqueous sodium chloride. The diagram shows a cell with a graphite cathode on the left and a graphite anode on the right. The electrolyte is concentrated sodium chloride solution. Part A says, the electrolyte contains sodium plus and chlorine minus ions. Write the formula of the other 2 ions in the electrolyte. Concentrated sodium chloride solution also contains water, which partially ionizes into ions. The other 2 ions are hydroxide ion, written as OH-, and hydrogen ion, written as H+. Before you start answering the part for the equations, you need to know what reduction is and what oxidation is. So reduction is the gain of electrons, it occurs at cathode, and oxidation is the loss of electrons, and it always occurs at the anode. Never forget those definitions when you're asked to answer questions on electrolysis. Now let's get back to business. Part B says, construct equations for the reactions at the Part B, Part 1, cathode. At the cathode, reduction takes place. Hydrogen ions are preferentially discharged over sodium ions because sodium is far too reactive to be discharged. The equation is 2H plus 2 electrons gives H2 gas. Part B, Part 2, anode. At the anode, oxidation takes place. Chloride ions are discharged first over hydroxide ions because the sodium chloride solution is concentrated. The equation is 2Cl- gives Cl2 gas plus 2 electrons. Part C says, suggest why the concentration of sodium hydroxide in the electrolyte increases as the electrolysis proceeds. As electrolysis continues, hydrogen ions are removed at the cathode and chloride ions are removed at the anode. The sodium ions and hydroxide ions that remain in the solution are not discharged. As more and more of these ions accumulate in the solution, the concentration of sodium hydroxide gradually increases over time. Part D says, state the chemical test for the product at the anode and state one of its uses. The product at the anode is chlorine gas, and its chemical test done by holding a damp blue litmus paper near the gas. As a result, it first turns red due to the acidic nature of the gas, and is then bleached to white due to the oxidizing nature of chlorine. Then the one use of chlorine is that it is used to sterilize drinking water to kill harmful bacteria and make it safe to drink. Part E says, in another experiment, 4.6 grams of sodium metal was produced by electrolyzing molten sodium chloride. Calculate the volume of chlorine gas produced at the same time at room temperature and pressure. Given the following overall equation, 2NaCl gives Cl2 plus 2Na. Let me work through this step by step. First, find moles of sodium produced. Molar mass of Na is 23 grams per mole. Moles of Na equals 4.6 divided by 23 equals 0.2 moles. From the equation, 2 moles of Na is produced alongside 1 mole of Cl2. So moles of Cl2 equals 0.2 divided by 2 equals 0.1 moles. At room temperature and pressure, 1 mole of any gas occupies 24,000 centimeters cubed. Volume of Cl2 equals 0.1 times 24,000 equals 2,400 cm cubed. That gives you your 10 marks for question B9. Question B10 reads, the contact process earns its name from the contact of the two gases on the surface of a solid catalyst to produce another gas X at 450 degrees Celsius. The reaction reaches a state of dynamic equilibrium. Part A says, identify Part 1 the catalyst used. Part 2X. The catalyst used is vanadium 5 oxide, written as V2O5. Gas X is sulfur trioxide, written as SO3. Part B says, one of the reacting gases is a pollutant. State the source of this gas. The two reacting gases in the contact process are sulfur dioxide and oxygen. Sulfur dioxide is the pollutant. Its source is the burning of fossil fuels such as coal and oil, and the roasting of sulfate ores during the extraction of metals in industry. Part C says, construct an equation, including state symbols, for the formation of X from the two gases. The equation is 2SO2 gas plus O2 gas with V2O5 as catalyst gives 2SO3 gas. Part D says, to produce X, manufacturers avoid increasing the temperature of the reaction that produces X. What does this suggest about the thermal nature of the reaction? The forward reaction that produces SO3 is exothermic, meaning it releases heat energy. According to Le Chatelier's principle, increasing the temperature would shift the equilibrium to the left, reducing the yield of SO3. That is why manufacturers use a moderate temperature of 450 degrees Celsius as a compromise between getting a reasonable yield and maintaining an acceptable rate of reaction. Part E says, outline how X is treated to finally obtain the sulfuric acid. Sulfur trioxide cannot be dissolved directly in water because the reaction is dangerously violent and produces a corrosive acid mist. Instead, SO3 is first absorbed into concentrated sulfuric acid to form a compound called oleum. Oleum is then carefully diluted with water to produce concentrated sulfuric acid. Part F says, give one commercial use of sulfuric acid. Sulfuric acid is used in the manufacture of fertilizers such as ammonium sulfate. That gives you your 10 marks for question B10. Question B11 reads, the following are the displayed structures of some organic compounds. The four structures are labeled A, B, C, and D. Structure A is ethane, 2 carbon atoms joined by a single bond with 3 hydrogen atoms on each carbon. Structure B is ethene, 2 carbon atoms joined by a double bond with 2 hydrogen atoms on each carbon. Structure C is ethanol, 2 carbon atoms with an OH group attached at one end. Structure D is ethanoic acid, 2 carbon atoms with a C double bond O and an OH group at one end. Part A. Part 1 says, which two compounds can react together to form an ester? The answer is C and D. Ethanol and ethanoic acid react together in a process called esterification to produce an ester and water. A catalyst of concentrated sulfuric acid and heat is used. Part A. Part 2 says, name the ester formed. The ester formed is ethyl ethanoate. Part A. Part 3 says, which compound is the least reactive? Name the compound. The answer is a ethane. It is a saturated hydrocarbon with only single bonds. It does not decolorize bromine water and is very unreactive under normal conditions because there are no double bonds available for addition reactions. Part B. Part 1 says, draw the structure of the polymer formed by compound B, showing only 3 repeating units. Compound B is ethene. The polymer formed is polyethene. Let me teach you how to draw it very clearly. Draw a long chain of 6 carbon atoms in a row connected by single bonds. Each carbon has 2 hydrogen atoms attached, one pointing up and one pointing down. Group the carbons in pairs to represent the 3 repeating units. You can draw brackets around each CH2 to CH2 group to clearly show the repeating unit. For 3 units, show 3 of these pairs joined together in a continuous chain. Part B, Part 2 says, name the compound which would rapidly decolorize bromine water. The answer is compound B, ethene. It is unsaturated and contains a carbon-to-carbon double bond. When ethene is added to bromine water, an addition reaction takes place. The bromine molecule adds across the double bond, removing the color. The orange bromine water turns colorless. Part B, Part 3 says, name the compound. Looking at the structure of polymer X in the diagram, which shows a carbon backbone with chlorine atoms attached to alternating carbons, the name is polyvinyl chloride, commonly known as PVC. Part C, Part 1 says, between X and Y give 2 similarities. Both X and Y are polymers made from repeating monomer units. Both are long-chain molecules produced through a polymerization reaction. Part C, Part 2 says, give 2 differences. First difference. X is an addition polymer while Y is a condensation polymer. Second difference. X contains chlorine atoms in its repeating unit, while Y contains ester linkages with carbon double bond oxygen groups in its repeating unit. Part C, Part 3 says, what is the best way of disposing of these polymers? The best method of disposal is recycling. These polymers are non-biodegradable, meaning they do not break down naturally in the environment. Burning them releases toxic gases, including hydrogen chloride from PVC. Recycling reduces environmental pollution and conserves raw materials at the same time. That gives you your 10 marks for question B11. Finally, question B12. It reads, a student investigates the rate of the reaction between magnesium ribbon and 1.0 molar hydrochloric acid. The equation is Mg solid plus 2HCl aqueous gives MgCl2 aqueous plus H2 gas. The volume of hydrogen gas produced is then measured at regular intervals. Part A says, draw the experimental setup that would enable the student to measure the volume of hydrogen at regular intervals. Let me describe this diagram step by step so you can draw it clearly. Draw a conical flask sitting on a bench. Inside the flask, draw a piece of magnesium ribbon and show liquid to represent the hydrochloric acid. Fit a rubber bung or stopper tightly into the top of the flask so no gas escapes from the top. From the bung, a delivery tube leads out and connects to a gas syringe positioned on the side. Label the contents of the flask as magnesium and 1.0 molar hydrochloric acid. Label the gas syringe. As hydrogen gas is produced, it pushes into the syringe and the plunger moves outward. The volume is read directly from the syringe at regular time intervals. Part B says, the following data was obtained. Time in minutes 0, 1, 2, 3, 4, 5, 6, 7. Volume of hydrogen in cm cubed. 0, 14, 23, 31, 38, 40, 40, 40. Part C, Part 1 says, plot the results on the grid provided on page 18. Label the horizontal axis as time in minutes going from 0 to 7. Label the vertical axis as volume of hydrogen in cm cubed going from 0 to 40. Plot each point carefully using a pencil. Then draw a smooth curve that rises steeply from 0 at the beginning, gradually slows between minutes 3 and 5, and then becomes completely flat at 40 centimeters cubed from minute 5 onwards. That flat horizontal line shows the reaction has stopped because the limiting reactant has been fully used up. Part C, Part 2 says, explain how the rate of reaction changes with time. At the start of the reaction, the rate is fast because the concentration of hydrochloric acid is high. This means there are many successful collisions between acid particles and magnesium atoms per unit time. As the reaction proceeds, the acid is gradually used up, so its concentration decreases. Fewer successful collisions occur per unit time, and the rate of reaction slows down. Eventually, the rate becomes 0 because all the hydrochloric acid has been completely used up. Part C, Part 3 says, sketch on the same grid on page 18 the curve obtained if 0.5 molar hydrochloric acid was used instead. keeping the quantities of the reactants constant. The new curve starts at 0 on the same graph. It rises more slowly and less steeply than the original curve because the lower concentration means fewer collisions occur per second, giving a slower rate of reaction. However, the curve must eventually reach exactly the same final volume of 40 centimeters cubed. The reason is that the same quantity of magnesium is present, and magnesium is the limiting reactant. Only the rate changes, not the total amount of gas produced. Draw the new curve below and to the right of the original curve, flattening out later but finishing at the same height of 40 centimeters cubed. That gives you your 10 marks for question B12. And that completes the entire paper. And that is a complete revision walkthrough of the Chemistry GCE Paper 2 from August 2025. We read every question exactly as it appeared on the paper and explained every answer in detail. Go back and replay any section you found difficult. Focus especially on the particle diagrams, the half equations for electrolysis, and the mole calculation steps because those are the areas where most marks are either gained or lost. Work hard, stay consistent, and I will see you in the next one.